Hello everyone. The title of this video is Use Polynomial Multiplication to Multiply Radical Expressions. Alright, so in this video I'm going to be working on several exercises taken directly from a free online textbook at openstacks.org. This is their Intermediate Algebra 2nd edition text. And the exercises I'll be working on are the even numbered exercises. If you notice the odd numbered ones you can click on and it'll take you to the solution. So I'm going to work on the ones that don't have a solution posted. And example 1 will be exercise number 192. Example 2 will be 194. Example 3 will be 196, and so on, all the way down to I'm going to be working up to exercise 216 from these exercises under the heading Use Polynomial Multiplication to Multiply Radical Expressions. I also have timestamps in the description of the video for each of these. So in the timestamps, example 1 will start exercise 192, example 2 will start exercise 194, and so on, for all the even numbered examples. So if you'd like to look at a specific question, you can just go to that particular timestamp. And one other thing I would request of you is that when I bring up a new question, try to work on it, pause the video and try to work on it yourself first before you watch me do it. And then watch me do it and compare it to how you did and see how you did. Because if you're just watching me do these things without practicing yourself, chances are you're not going to be learning all that much. Alright, so the first example, the first question is exercise 192, and I've got this written out on some paper. Now, as the title said, it's use polynomial multiplication to multiply radical expressions. So we're going to be doing a lot of distributing here. So number 1, exercise 192, part A. Say I have the square root of 11 multiplied by, and then a sum, right? Something with two terms, 8 plus 4 times the square root of 11. So, and this is where the whole polynomial multiplication comes in, I'm just going to be distributing, the square root of 11 to this, both terms of the 8 plus 4 times the square root of 11. All right. So we have 8 times the square root of 11, or the square root of 11 times 8 if you wish. Now these can't be multiplied together. Like what I mean by that is, don't turn this into the square root of 88. 8 is not a radical. The square root of 11 is a radical. You cannot put those together. All right. The only things you can multiply together are radicals. Radicals with radicals and non-radicals with non-radicals. Right. So we have 8 times the square root of 11 plus, and then 4 times the square root of 11 times the square root of 11, right? Square root of 11 again. Okay. Well, again, you don't really do anything with these two because one's a non-radical factor, the other's a radical factor, so that's simply 8 times the square root of 11 plus, and then here, the non-radical factor is 4, but the two radical factors I can multiply together. Right, the square root of 11 times the square root of 11. Well, I'm hoping you're seeing that that's just going to be 11, right? Because that's going to be the square root of 121, or the square root of 11 squared. So I'm going to skip ahead and say that's just 11. And then 4 times 11 I can simplify, right? 4 times 11 is 44. So I have 8 times the square root of 11 for the first term, plus, and then just 44. And this is honestly as simplified as this gets, because you can't combine these. Don't put the 8 and the 44 together to make 52 times the square root of 11. Right? You can't put these together because this term has the square root of 11 attached to it, and this term does not. So these do not have like radicals. Right? You cannot combine these. And the radical is as simplified as it gets. Right? The square root of 11 doesn't simplify any further. So this is it. That is as simple as this expression would get. Now, just for this first page, and you can do it for the other pages if you wish, I'm going to use a calculator to test my answers, to check my results. So I have a TI-84 Plus emulator that I'm going to pull up. Here it is. And I'm going to enter the expression we were first given. All right, so we have the square root of 11 that times the quantity 8 plus 4 times the square root of 11. And then close the parentheses. All right, let's see what we get. So that's 70.532,998,32, and so on. All right, so that was the expression I was originally given. Next, I'm going to put in the final expression I got, right, this simplified ending version here, and see if we get the same result. All right, so I ended up with 8 times the square root of 11, right, or 8 root 11 like this, then plus 44. And look at that. It's exactly the same value. Now see what happens. Now remember I said don't put these together, right? Very often people will make that mistake and put the 44 with the 8 and say this is equal to 52 times the square root of 11. Let's see what happens on the calculator here. See how that's not the same number? 172 something? So you would know you did something wrong. Okay. So yeah, so 8 times the square root of 11 plus 44 is correct. All right, great. All right, same thing for the next expression, part B. I have one term times two terms, right? A number times a sum. So again, it's just distributing that one term. So I'm going to take this cube root of 3, multiply it by the cube root of 9, plus, and then again the cube root of 3 times the cube root of 18. Which, these are both radicals, both the same root. So I can multiply them together. Right? It wasn't like the 8 and the square root of 11. One was a radical, one was not. Here, these are both the same radical. They're both cube roots. So that's the cube root of 3 times 9, which is 27. Right? You can do that because they're both cube roots. Right? Plus, and again, both cube roots. So I can multiply them together with the product property. Cube root of 3 times the cube root of 18 is the cube root of 54, right? 3 times 18. But then we need to simplify these. Right? Now the cube root of 27 is just 3. Right? 3 to the third power is 27. And I'll do this off to the side here. The cube root of 54, 54 is not a perfect cube, but there, is a perfect cube that goes into this evenly, and that'd be 27. This is the cube root of 27 times the cube root of 2. Which is 3 times the cube root of 2. So that's going to go here. Right? So we have 3 plus 3 times the cube root of 2. And that's it. Do not add these 3's. These are not like radical terms. Right? this term is just a constant, I mean, they're both constants, but this term doesn't have a radical, and this term does. So they cannot go together. They do not have like radical terms. So this is it. Just 3 plus 3 times the cube root of 2. And once again, I am going to bring up a calculator, and we'll punch in these expressions, the one we started with and the one we ended with, and see if they are indeed the same value. Alright, so the first expression I was given, for this I gotta hit the math button, hit the number 4 to get the cube root up. Again, hopefully you can figure out how to get cube root and 4th root, 5th root, whatever roots on whatever calculator you're working on. So I got the cube root of 3 times, and then the quantity, cube root of 9, then plus, then cube root of 18, close the parentheses. So that's the expression we started with. Alright, and that has a value of 6.77976315 and so on. Now I'm going to enter the expression I ended with. Alright, 3 plus 3 times the cube root of 2. And look at that, right? It is indeed the same value. Great. And as I said before, don't just add the 3's, right? And if you're checking yourself with a calculator afterwards, you'll know if you made a mistake. Because if I add, if you added the 3's and said, oh, this is 6 times the cube root of 2, if I entered that in, 6 times the cube root of 2, see, that's not the same number. That's not the same number as the original expression, so you would know that you were wrong there. Right. Again, radical terms cannot be added with non-radical terms, right? You can't add terms that don't have like radicals. Okay? Alright, so I'm just going to do that checking with the calculator for this first page and leave the rest for you to check. Great. Alright, so the next page, the next question, number 2, which corresponds to exercise 194. Same setup. Alright. So each of these, part A, you have one term times 2 terms. So I'm distributing. So the square root of 2 will be distributed to this -5 term plus, and then the square root of 2 times 9 times the square root of 2. Alright, so the first term is just going to be -5 times the square root of 2. You can't really do anything else with that, right? Because one is a radical factor, the other one's non-radical. You can't make that, don't make that the square root of -10 or negative square root of 10. Those don't go together. One's a square root, one's not. So it's just simply -5 times the square root of 2, the end. Plus, and then 9 times the square root of 2, times the square root of 2 again. But the square root of 2 times the square root of 2 is just 2. So we end up with this, -5 times the square root of 2 for the first term, plus, and then 9 times 2, or 18, for the second term. And that's it. I'm done with the distributing, I'm done with the simplifying. And once again, do not add these. Alright, one has a radical, the other does not. You cannot add those. Okay, great. Number 2, part B. Again, I have a one-term expression multiplied by a two-term expression. So I need to distribute the one term to the two terms. Now, every single one of these is a 4th root, right? So I can multiply them using the product property. Right, so 4th root of 2 times the 4th root of 12 would be the 4th root of 2 times 12, or 24. Plus, then the 4th root of 2 times the 4th root of 24. would be the fourth root of 2 times 24, or the fourth root of 48. All right, now let's see if we can simplify these radicals. Now I'm looking for a fourth, it's fourth roots. So I'm looking for fourth powers that go into these radicands evenly. Now 24, that's 2 times 12, this is 2 times 6, 2 times 3, it's 2 cubed times 3, 8 times 3. There is no fourth power that goes into 24 evenly. So that is as simple as it gets, that first term, the fourth root of 24. But the fourth root of 48, on the other hand, that can simplify. 16 goes into 48 evenly, right? 16 times 3. And 16 is a fourth power. 16 is 2 to the fourth. So this can be broken up with the product property as the fourth root of 16 times the fourth root of 3, which would be 2 times the fourth root of 3. Right, and that's what's going to go here. So we end up with the fourth root of 24 plus 2 times the fourth root of 3. And this is it. This is it. Now yes, they are both radical terms, but they don't have a like radical. They don't have a common radical. They both have fourth roots, fine, but they're fourth roots of totally different radicands, right? This has the fourth root of 24. This term has the fourth root of 3. So you can't put those together. That's it. Fourth root of 24 plus 2 times the fourth root of 3. Great. All right, so far, we've only seen examples where there's been a one-term expression times a two-term expression. Well, now in number 3, which is exercise 196, we're seeing a two-term expression, 8 minus the square root of 2, multiplied by another two-term expression, 3 plus the square root of 2. So we're going to be distributing a lot, but remember foiling, right? You could call it foiling if you wish, but you multiply these just like multiplying polynomials. How do you multiply a two-term polynomial by another two-term polynomial? Well, you take each term from one of them and distribute to the other, and then combine any like terms. So first I'll start with the 8. I distribute the 8 to the 3 and the positive square root of 2. Right, so I'll start with that. So we have 8 times 3, which is 24, plus, and then 8 times the square root of 2, which will be written exactly that way, 8 times the square root of 2, right? You can't put those together because one's a radical factor and one is not. Okay, so I'm done multiplying the 8. So now that I'm done with the 8, let's move over to the negative square root of 2 term and distribute that to the 3 and the square root of 2. So we have negative square root of 2 times positive 3. That would be negative 3 times the square root of 2. And then negative square root of 2 times positive square root of 2 would be negative square root of 4, which is 2. All right. Negative square root of 2 times positive square root of 2 would be negative, because it's a negative times positive. And then you saw before, square root of 2 times square root of 2 would be the square root of 4, which is just 2 again. Right? So we have minus 2 at the end. And then I combine like terms with like radicals. Right? 24 and negative 2, those are both non-radical terms. Those can go together. 24 plus negative 2 is 22. And then these two terms have like radicals. They both have the square root of 2 involved. And remember how to combine terms with like radicals. 8 times the square root of 2 minus 3 times the square root of 2. 8 minus 2 would be 5, positive 5 times the square root of 2. And that's it. And then these two terms don't go together. as they do not have a like radical. That's it. All right, and once again, I'll leave this to you. Check with a calculator, Take 8 minus the square root of 2 and multiply it by 3 plus the square root of 2 and see that you get the same exact result as if you just take 22 and then add 5 times the square root of 2. And you should get the same result. Okay, wonderful. And we're going to be doing this, right, the foiling or the just a bunch of distributing for the rest of the video, not the rest of the video, but for a lot of the rest of the examples. All right, so number 4, that corresponds to exercise 198. I'm doing the same stuff, right? So I have, 2 terms, 3 minus 2 square roots of 7 times another 2-term expression, 5 minus 4 square root of 7. So first I'll distribute the 3 to this 5 minus 4 square root of 7. Okay, so 3 times 5 is 15. And then 3 times negative 4 is negative 12 times the square root of 7. Right? Don't forget the times the square root of 7. All right, and I can only multiply the 3 and the negative 4 because those are the non-radical factors. And then, I can't multiply that by the square root of 7. Make the square root of 84 or something like that. Because one's a radical factor, one's not. So it's just minus 12 square root of 7. And now I'm done with that. And move over to the negative 2 square root of 7 term and distribute that to the 5 and negative 4 root 7. Alright, so negative 2 times the square root of 7 times positive 5 would be negative 10 times the square root of 7. And then negative 2 times the square root of 7 times negative 4 times the square root of 7 would be positive 8, right? Multiply the negative 2 and negative 4, the non-radical factors, times the square root of 49, which is just 7. So this last term here is, positive 8 times 7, that's 56. And then I combine like terms and, terms with like radicals. You have positive 15 combined with positive 56 would be positive 71. Right, the 15 and the 56. And then the two terms with the like radicals, square root of 7, put those coefficients together would be minus 22 times the square root of 7. And again, these cannot combine. Right. And once again, I leave it to you to check with a calculator that the original expression and this final expression are the same. Okay. Next, part B. Now we have some variables involved. And when there are variables involved, usually I like to state the domain, what's allowed to be used, what's allowed to be plugged in for those variables. Now, these are both odd roots, right? Cube roots. And if you recall, you can take the odd root of any number, positive or negative, or 0. So x can be any real number, right? So I'm not going to worry about writing any restrictions. So now comes the distribution, right? I've got, again, 2 terms times 2 terms. So you take every term from one, distribute to the other. So I'm going to take this cube root of x and multiply it by the cube root of x and this negative 3. Now remember, cube root times cube root. I can put those together. So that'll be the cube root of x times x, or the cube root of x squared. And then the cube root of x times negative 3 is just going to be, negative 3 times the cube root of x. That's all you can do with that. Alright, one's a radical factor, the other is not. Alright, so now I'm done with the cube root of x. Let's move over to the negative 5 term and distribute that. So negative 5 times the cube root of x is exactly that. Just write negative 5 times the cube root of x. And then negative 5 times negative 3 is positive 15. And then I combine any like radical terms or like terms. Cube root of x squared doesn't simplify, so that's going to be as is, right? Just the cube root of x squared. These two terms are like, they have the like radical cube root of x. So I combine their coefficients, that'll be minus 8, right? Minus 8 times the cube root of x. And then you have plus 15. That doesn't go with any other term. So this ends up being the cube root of x squared minus 8 times the cube root of x plus 15. And if you'd like to test it out, just replace x with any number you want. Right? X can be any real number here. Replace x with any number you want, 0, 1, 5, negative 10, whatever you want. Punch in this, plug it into the original expression and punch it in a calculator. Plug it into the last expression here, punch it in a calculator, and it should give you the same number result for any value of x. But I leave that to you. Alright. The next example, very similar, the next question, number 5, which is corresponding to exercise 200 in that text. So starting out the same way here, you have part A, 2 terms times 2 terms again. So I'm doing that foiling, right? Taking the 7, distributing it to the 4 and the positive 9 square root of 5. And then I'll take the negative 2 times the square root of 5 and distribute that as well to the 4 and 9 square root of 5. Alright, so starting with the 7. 7 times 4 is 28. Then 7 times 9 times the square root of 5, that's 63 times the square root of 5, right? So plus 63 times the square root of 5. So now I'm done with the 7. Move over to the negative 2 times the square root of 5. Negative 2 times the square root of 5 times 4 would be negative 8 times the square root of 5. And then negative 2 times the square root of 5 times positive 9 times the square root of 5 would be negative 18 times the square root of 25. Right? Square root of 5 times square root of 5, so times 5. This negative 18 times 5 would be negative 90. Right? And then I combine like terms and terms with like radicals. Let's see, 28 and negative 90. Negative 62. Right, it'd be negative 62 when I combine the 28 and negative 90. And then the like radical terms, these terms with the square root of 5, just combine the coefficients. 63 minus 8 would be 55. Right, positive 55 times the square root of 5. Right? Combining the like radical terms, and again, these don't go together, right? Because one's a radical term and one is not. Okay, and once again, I leave it to you to punch this in a calculator, punch this in a calculator, check, and see if they're the same value. Alright, part B, same stuff. Just another 2-term expression times another 2-term expression, so I'm doing lots of distributing. Taking the 3 times the cube root of x from this expression and distributing to those 2 terms, the cube root of x and the minus 2. And then I'm taking the positive 2 and distributing that as well. Alright, so the 3 times the cube root of x times the cube root of x again. The cube roots of x can be multiplied, so we have 3 times the cube root of x times x, or just x squared. And then 3 cube root of x times negative 2 would be negative 6, right? You multiply the non-radical factors. Negative 6 times the cube root of x. Alright, so now I'm done with the 3 cube root of x. Move over to the positive 2 and distribute that. So I got positive 2 times the cube root of x. That'll be the next term. And then positive 2 times negative 2 is negative 4. And the only terms that can be combined here are these like radical terms with the cube roots of x. So I end up with 3 times the cube root of x squared, and then negative 6, plus 2 times the cube root of x would be negative 4 times the cube root of x, and then minus 4 at the end. And again, none of these terms have like radicals, so none of them get combined. That's it. Once again, this is an odd roots. These were odd roots, so x can be any number, any real number. Replace x with any real number you want, and check the value of the original expression. Check the value of the final expression. Right? Should be equivalent, no matter what value of x you plug in. Okay. Moving on. Number 6, which is exercise 202. Same stuff. 2 roots, 2-term expression times another 2-term expression. So first I'm going to distribute this square root of 11. Okay. Now first we'll have the square root of 11 times square root of 11 is 11. That would be the square root of 121, which is 11. And then the square root of 11 times positive 6 times the square root of 5. And the only factors I'd multiply here would be the square roots. So you have 6, positive 6 still, and then the square root of 5 times square root of 11 would be the square root of 55. Right, using that product property for radicals. Okay, now I'm done with the square root of 11. Let's distribute the square root of 5 now. So the square root of 5 times the square root of 11 would be positive 1 times the square root of 55. And then the square root of 5 times 6 times the square root of 5 would be 6 times the square root of 25. Right? Or just 6 times 5, right? Which is 30. That last term is 30. And then combining like terms, you have 11 and 30 go together to make 41. So 41, and then the 2 terms with the square root of 55 can go together, making 7. You have 6 plus 1. It's plus 7 times the square root of 55. All right, and those 2 terms don't go together, so I'm done. Oh, and the square root of 55 does not simplify any further, right? 55 is 5 times 11. There are no perfect squares that go into 55 evenly, other than 1. And once again, I leave it to you to check with a calculator. All right, number 7 is very similar, right? Exercise 204. So once again, I'm distributing, right? 4 times the square root of 6. I'll distribute that first to this 8 times the square root of 6 and negative 3 times the square root of 13 term. Alright, so 4 times the square root of 6 times 8 times the square root of 6. If you multiply the non-radical factors, that's 8 times 4, that's 32, times, and then multiply the radical factors, square root of 6 times square root of 6 is the square root of 36, which is just 6. So the first term is 32 times 6, which I'll write out in a little bit. Right? I mean, 190, I'll just do it now. It's 192. Right? 180 plus 12. Okay, so 192. And then you have 4 times the square root of 6 times negative 3 times the square root of 13. Again, you multiply the non-radical factors. 4 times negative 3 would be minus 12. And then multiply the radical factors. Square root of 6 times square root of 13 would be the square root of 78. Right, 60 plus 18. So we get 192 minus 12 times the square root of 78. All right, so I'm done with the 4 root 6. Now I'm going to move over to the positive 7 times the square root of 13 and distribute that. 7 times the square root of 13 times 8 times the square root of 6. Again, you multiply the non-radical factors. 7 times 8 is positive 56 times, and the radical factors. Square root of 6 times square root of 3 is the square root of 78. And that term will go together with the negative 12 times the square root of 78 we had a second ago. And then finally, we have 7 times the square root of 13 times negative 3 times the square root of 13. 7 times negative 3 is negative 21 times, and then square root of 13 times square root of 13 is just 13. Okay. And if you multiply 21 and 13, 21 times 10 would be 210, plus 21 times 3 is 63. That's 273. All right, 210 plus 63. Yeah. And then we combine like terms and terms with like radicals. Now we have here 192 minus 273. All right, 192 minus 273. All right, well, that would be 81, negative 81. All right, yeah, 81 plus 192 would be 273. Yeah, that works. All right, and then combining the like radical terms, and you just combine the coefficients, both of these. Now the square root of 78 doesn't simplify any further, right? 78 is 2 times 3 times 13. There are no perfect squares that go into 78, so that's as simplified as it gets. Just combine the coefficients of these terms with like radicals. And negative 12 plus 56 would be 44. All right, positive 44 times the square root of 78. And that's it. That's as, these don't go together. One term is radical, one term is not. And again, I leave it to you to double check this on a calculator. See if you get the same value. All right, next question. We're pretty much going to be doing the same thing, just all the foiling and distributing, but it's written a little differently here. All right, it's written a little differently. So number 8 is exercise 206. Now we're dealing with squares. We take something with two terms and square it. Now hopefully you recall that if you take an expression with two terms, a plus b, a minus b, whatever, and square it, that means a plus, you multiply the expression by itself. That's what it means to square. And when you FOIL and all that, combine like terms, you end up with a squared plus 2ab plus b squared. And if it were minus, you'd end up with minuses instead, minus 2ab plus b squared. So don't distribute the square, right? This is not 16 plus 11. This is not 27. All right. Don't distribute the square, right? I'll write that here. A plus b squared is not a squared plus b squared, right? As you can see from up top here. All right, but that is a huge mistake. That is a mistake that is made very, very often. Please don't do it. So like I said, this is 4 plus the square root of 11 multiplied by itself, right? Squared times 4 plus the square root of 11 again. And then just like all the earlier problems, this recent several examples, I'll start by distributing the 4, right, to the 4 and the square root of 11. So, 4 times 4 is 16, plus 4 times the square root of 11 is exactly written that way, 4 times the square root of 11. Can't be anything else doing with that. Now I'm done with the 4, move over to the square root of 11 and distribute that. Square root of 11 times 4 is, 4 times the square root of 11, so I got plus 4 times the square root of 11. And then square root of 11 times square root of 11 is 11, right? The square root of 121. And then combining like terms, the 16 and the 11 make 27. But then you have 4 root 11 plus 4 root 11, that's 8 times the square root of 11. Right? And there you go. And these don't go together. Right? And again, check it out with the calculator. Take 4 plus 11, square root of 11 in parentheses and square it. And then punch in 27 plus 8 times the square root of 11. And you should get the same result. Okay, no different for part B. You have this expression with two terms squared. Just remember what it means to square. It means you're multiplying that expression by itself. So 3 minus 2 square root of 5 times 3 minus 2 times the square root of 5 again. So first I'll distribute the 3. 3 times 3 is 9. 3 times negative 2 square root of 5 is negative 6 square root of 5. And then I'll distribute the negative 2 square root of 5. So negative 2 times the square root of 5 times 3 would be negative 6 times the square root of 5. And then negative 2 times the square root of 5 times negative 2 times the square root of 5, right? Multiply the non-radical factors. Negative 2 times negative 2 is positive 4 times, and then the square root of 25, which is 5. So this last term is plus 20. So putting this all together, 9 plus 20 is 29. And then the two radical terms put together would be minus 12 times the square root of 5. Combining like radicals, and that's it. 29 minus 12 times the square root of 5. And again, you can double check with a calculator if you wish. Alright, number 9 is very similar. Number 9 is exercise 208. And once again we have a binomial or a two-term expression squared. So I'll do it again. What does it mean to square something? Multiply it by itself. So we have 5 minus the square root of 10 times 5 minus the square root of 10 again. First I'm going to distribute the 5, and I'll just write one arrow here. 5 times 5 is 25. Then 5 times negative square root of 10 would be negative 5 times the square root of 10. Alright, now I'm done with the 5. Move over to the negative square root of 10 and distribute that, right? I guess I put 2 arrows there. Negative square root of 10 times 5 is exactly that, negative 5 times square root of 10. And then negative square root of 10 times negative square root of 10 would be positive 10, right? Positive square root of 100, which is 10. And then the 25 and 10 go together, that's 35. And then the two terms of the like radical go together, making minus 10 times the square root of 10. And there we go. And these don't go together, right? One's radical, one is not. 35 minus 10 times the square root of 10. Great. And again, I leave it to you to check with a calculator. Alright, same for the next one, right? Another square. So again, that means multiply it by itself. So 8 plus 3 times the square root of 2 times, again, 8 plus 3 times the square root of 2. Alright, so first I'll distribute the 8. So 8 times 8, 64, plus 8 times 3 times the square root of 2 would be 24 times the square root of 2. And then we have that again when we distribute the 3 square root of 2, right? 3 square root of 2 times 8 is another 24 times the square root of 2. And then 3 square root of 2 times 3 square root of 2 would be 9 square root of 4. So plus 9 times 2, which is 18. Right, that last term would be 18. Then combining like terms in terms with like radicals, 64 plus 18 would be 82. And then the two like radical terms would be 48 square roots of 2. Right. And there you go. 82 plus 48 times the square root of 2. Fantastic. Okay, next question. Doing the same stuff. Now, you can keep doing what we're doing. Alright, I'll show you. So we have number 10, which is exercise 210. You have 7 plus the square root of 10 multiplied by 7 minus the square root of 10. You might recognize these as what are called, conjugates. Right, and for the rest of the video, we're going to be working with examples where we are multiplying these conjugates. So you can still do it the long way. Distribute the 7. 7 times 7 is 49. 7 times negative square root of 10 would be negative 7 square root of 10. And then I move to the square root of 10 and distribute that. So you have positive 7 times the square root of 10. And then positive square root of 10 times negative square root of 10 would be negative square root of 100, or negative 10. And you see I end up with 49 minus 10, which is 39. And then these like radical terms add up to 0, because they're opposites. So I end up with just 39. Pretty simple. So you can still do it the long way like this. But if you remember that multiplying two binomial conjugates results in a difference of squares, that'll make this really easy, these problems really easy, right? So if you have a plus b multiplied by its conjugate, a minus b, you end up with a squared minus b squared, right? Just a difference of squares. So notice here how this ended up being 7 squared minus the square root of 10 squared. So 49 minus 10, 39. Right? Reason being is those middle terms will cancel out. Right? They'll disappear. So I'm going to use this for the rest of the time. Right? The fact that we are multiplying conjugates. But you have to recognize that you're multiplying conjugates in order to be able to use this difference of squares. So number 11, which is exercise 212, same thing. Multiplying these conjugates, right? It's a plus b times a minus b, where a is 1 and b is this 8 times the square root of 2. Right? So 1 plus 8 times the square root of 2 times 1 minus 8 times the square root of 2 would be 1 squared minus, and then 8 times the square root of 2 squared. Now 1 squared is 1 minus an 8 square root of 2 times 8 square root of 2 again would be 64 times 2. Right, because 8 times 8, you multiply the non-radical, 8 squared is 64 times, and then the square root of 2 squared would just be the square root of 4, which is just 2. So we end up here with 1 minus 128, which ends up being negative 127. Negative 127. And this is exactly the same thing I would have gotten if I distributed the 1 then distributed the 8 square root of 2, and then combined like terms. Negative 127. And once again, punch this original expression in a calculator and see, do you get, negative 127 back? And you should. All right, I got one more page here, 2 more exercises. All right, number 12 is exercise 214. And once again, we are multiplying conjugates. 9 minus 4 root 3 times 9 plus 4 root 3. So since I'm multiplying two binomial conjugates, I'll end up with the difference of squares. I'll end up with 9 squared minus, and then 4 times the square root of 3 squared. Now 9 squared is 81 minus, and then 4 squared is 16, square root of 3 squared is just 3, so you have 16 times 3, which is 48. So you have 81 minus 48, which is 33. All right, so you end up with 33 here. And again, I leave it to you to check with a calculator, punch in the original expression and see if you get 33 back, and you should. All right, and the final one, again, I have conjugates. All right, the cube root of 4x plus 3 times the cube root of 4x minus 3. All right. So because I recognize these as binomial conjugates, two-term conjugates, I'm just going to end up with a difference of squares. The cube root of 4x squared, so cube root of 4x times cube root of 4x minus 3 squared. Right. So this is the cube root of 16x squared. Right. Minus, and then 3 squared is 9. And this is great and everything, but this radical is not totally simplified. Because there's, I'm taking a cube root here, there is a perfect cube that goes into 16x squared evenly, and that would be 8, right? 8 is 2 cubed. So off to the side here, the cube root of 16x squared would be the cube root of 8 times the cube root of 2x squared, right? And the cube root of 8 is just 2, right? So 2 times the cube root of 2x squared, that's going to go here. So we have 2 times the cube root of 2x squared, right? And then after that, minus 9, and these don't go together. And once again, I leave it to you to test this out. Since these were odd roots, you can replace the variables with anything. Replace x with any number you want. Replace x with 0, 5, negative 7, whatever. 2 thirds, negative 5 halves, whatever you want. And plug it in the original expression, see what you get. Plug it in this final expression for x and see that you get the same value. You should. If everything, they should have the same value no matter what you choose for x. But again, I leave that to you. All right, wonderful. All right, so I'm hoping that watching me go through these 13 questions here help you in some way when you are asked to use polynomial multiplication to multiply radical expressions, or just to multiply and simplify radical expressions in general. All right. And thank you very much for watching.